Okay, so now we return to question C. In question C, we'll investigate this MR drop zone a little further. So in the question it says, within which range must the marginal cost value be in order for the optimal price to be within the range of the MR drop, also called MR gap value. So what they're talking about here is this drop here. So as I mentioned in the last video, we could have had circumstances where MC could have intersected in the drop zone. So if we had an illustration of it, then we would know if it intersects in the top, middle, or below. But how can we calculate it? Because if you are at the exam, solving the exam, you'll want to have a method where you're not depending on your graph. You'll want to have a method where you can check that what you think is correct, for example, based on an illustration, a sketch, or something else like that, you'll have to have a method where you can actually verify if that is true. So what we're going to do is we're going to use these two MR formulas. Remember, the first one belongs to the interval of 0 to 12,000 and the second interval above 12,000. The reason why I haven't put an equal sign on both of them is because of the drop. So in Managerial Economics, we use equal sign both places where the function has a kink. But if it drops or jumps, then we show here where at what interval 12,000 belongs to. It belongs to this one. So I put a dot like with a full one here. But here I put a hole here in the dot, and that is because we don't have an equal sign there. This is how you show it graphically. So how you show graphically which interval the function belongs to. And it doesn't matter if it belongs to 1 or 2, you just have to decide. It's just a method of showing that the function drops. So let's look at that. So we have the kink value of 12,000. So this is where the action happens, right? So at the exam, let's just say you didn't do the illustration. Let's say you're sitting at the exam at home or solving this, and you want to know which interval does it intersect without having this graph. Then you have to calculate first and foremost the values of the drop, and then what is the MC value of the drop. So let's do that. So MR1 would be equal to minus 0.01 times 12,000 plus 180, giving us 60. MR2 minus 0.015 times 12,000 plus 210, giving us 30. So from this we can learn that the MR drop value is the interval from 30 up to 60. So this is what they ask for. We can put it into the graph also, of course. So this is like 60. Down here, we have the intersection 30. So, and between those we have MC. But what MC is when Q is 0, that is not what we want to know. We'll want to know what MC is out here. Is it up there, there, or there? And to do that, we just calculate the value of MC. So we have an MC function, which we calculated earlier, 0.004 Q plus 40. Thus, MC is 0.004 times 12,000 plus 40, and that is 88. So that is all the way out here, up there. So this is 88. So from there, we now know that the intersection must be at the top one. Because if we get an MC value at the kink that is above the interval, then we know it intersects above the drop. If we get an MC value that is between these 2 points, then we know it intersects in the kink. And if we get a value that is below 30, then we know it intersects at the second interval. So at the exam, just to sum it up, calculate MR drop, substitute the drop value of Q into your MC function, look at that number. If it's between the interval, if it's in the interval, it intersects in the drop zone, thus giving you the optimal price of the current price. If it's above, you set it equal to MR1, and if it's below, you set it equal to MR2. It is actually that easy. You just have to have a good method of doing this at the exam. So first, calculate the P functions, then calculate the MR functions, then calculate MR drop, calculate MC at the drop, compare that to the drop value, and from that you can conclude where the solution is here. So now we're finished with the question. It says within which range must it be for the optimal price to be within the, so within which range must the marginal cost value be in order for the optimal price to be within the range of the MR drop value? Then it has to be in that range. So if it's in the range of the drop, then you'll know that that is the correct answer. So now I'm just going to move outside the camera for a moment. Then you can pause the video and look at the whole, like both graph and calculations here at the same time without me standing in your way. And you can just pause the video, write it all down, and then play again, and then I'll have some final remarks before concluding this problem. So just pause the video when I'm outside the picture. Okay, so what I want to go through here at the end, we're finished with this subject, is some final remarks. First, asymmetric competitor behavior. That is what caused this kink. So what is asymmetric competitor behavior? That is what I'm going to just talk about right now, because if you get a question at the exam that is more theoretical than mathematical, you should be able to explain that also. Let me just make like, for example, exaggerate it a little, a kink like that. So what we're talking about here is we're talking about a case where as when we increase the price, then the quantity will fall greatly. But if we lower the price, the quantity will not fall that much. So why is this? That is what is explained in this concept of asymmetric competitor behavior. So this model is relevant in oligopoly, meaning few firms. Few firms in a game theoretical dilemma, looking at each other, reacting to each other's behavior of setting prices. So the story behind this is the following. If you as a company raise your price like that, then the competitor will not raise their price. So you'll be the only one with a large price. What does that mean? If there are few competitors at the market and you raise your price, but the others hold the prices, then you're the only one that's expensive, right? Then you'll lose a lot of quantity. Then you'll lose a lot of market share to the other companies. On the other hand, if you lower your price, the competitors will react differently. Asymmetric means different reactions. So if you raise the price, they won't follow, but if you lower the price, they will follow all the way down and match your price. So they follow down in price, meaning that you can't capture that much market quantity. So different reactions, whether if you raise or lower their price, thus meaning the king demand curve. So summing up, if you raise your price, you lose a lot of market share because they don't raise the price. If you lower your price, then you can't grab that much, then you can't gain that much market share because your competitors follow the way down and match your price decrease. This asymmetric competitive behavior thus giving you the king demand curve. The king demand curve then subsequently causing the MR drop. So the relation between the kink and the drop here is pure mathematical, but the relation between the competitor reaction and the kink is theoretical. That's where you're supposed to do what I just did, explain it. Maybe you can write some notes about what I just said, so you have like a standard sentence you can put in if this comes at the exam. But I want you to formulate it yourself. That's why I don't write it up at the board right now, because I don't want you all to have the same identical explanation to this. So take what I'm saying, formulate it in your own answer, have it ready at the exam. So if it comes, you just like bang into the solution, moving on, right? So now we're finished with one of the most relevant types of problems, oligopoly with the king demand curve. So I'm like focusing on the most relevant issues here, of course, because it's an exam course. So be sure that you understand what I've just went through. Be sure you understand it all. And be sure to look at my Excel sheet also, where I go through this, giving you illustrations in Excel. And if you want to do some of the calculations in Excel, feel free to do that also. I hope that you got a lot out of this video. And I hope now that you understand the concept of the king demand curve, both mathematically, graphically, and theoretically. Thank you for watching.